Hello, and welcome to Janus's weekly safety training. This week's IIPP topic is on negative air pressure units, also known as negative pressure machines or sometimes HOG. Previously, we talked about challenge testing these units and about how proper sealing of the critical barriers will help prevent poly from billowing off of walls. Today, we're going to talk about the difference between negative pressure and air changes per hour. Cal OSHA requires negative pressure containments only when Class 1 asbestos abatement work is being conducted. Class 1 work includes friable surfacing materials, fireproofing, cottage cheese or popcorn ceilings, and soft acoustic plasters, and thermal system insulation, pipe wrap, duct wrap, weather wrap, tank wrap, etc. However, Janus Corp uses negative pressure enclosures on many of our projects even when the removal work is not Class 1 asbestos work. Janus even uses negative pressure containment on projects when we are not conducting asbestos removal work, such as when we're removing lead, mold, or other potentially hazardous materials, whether they're required or not. Janus does this even when not required by regulations to help prevent airborne contaminants from escaping the work area and to help keep exposures to workers down while keeping oxygen levels inside containment up. We can see the amount of negative pressure we create by looking at a manometer. Cal OSHA wants a reading of at least 0.02 inches of water differential at all times when work is being conducted inside containment. Old manometers were simple U-shaped tubes with colored liquid. We had to measure the difference in how high the liquid was in each tube to figure out the pressure difference inside containment versus outside of containment. Today we use digital manometers. That gives us a digital reading on what the pressure differential is between inside and outside. The amount of negative pressure we can create, lower air pressure inside containment than air pressure in the adjacent exterior areas, depends mostly on how well we seal our containment. Critical barriers, any opening through which air can move that we seal, and the proper use of flaps on our entry, exit, and bag-out chambers are important in creating negative pressure and maintaining it. In multi-story buildings, we also need to think about negative pressure between the floor, where we are working, and the floors above and below us as well. This is especially important when working in hospitals and sites that may be operating exhaust fan for fume hoods, chemical safety, or negative pressure areas of their own, dust control in hospital and computer equipment manufacturers. We need to be aware of these type of building use before we install our critical barriers and set up our containments. Manometers on floor and above and below our work areas are also a good idea. Unoperable, supposedly sealed, unopenable windows tend to leak air. These windows that are glazed or caulked around the edges look to be sealed completely against weather and air leaks. However, if you install a negative air unit and blow smoke from a ventilation tube at the edges of the window, you will often find that these windows leak air, at least while the space inside is at a lower pressure than the exterior of the window. First, seal the critical barriers as well as possible everywhere except at the unopenable windows. Then turn on the negative air. Blow smoke at edges of windows from inside the work area. If smoke swirls, then seal the edges of the windows with blue painter's tape, or on a demolition project where windows will eventually be removed, duct tape is even better. This will prevent air movement from outside of containment to inside containment behind our wall poly. Opening multiple flaps at the same time, or worse, making it so flaps do not close at all on our entry-exit decon or our bag-out chambers, is not only improper, it also reduces, if not eliminates, the negative pressure difference between the inside of containment and the exterior adjacent areas. Do not tape flaps open. Do not put flaps between containment support, PVC or wood, and the exterior plastic of the containment. If flaps cannot close properly, negative pressure cannot be maintained properly. What you see in the pictures below is a tunnel, not a containment. It's not good for bag out, but it's terrible for negative pressure. Air changes per hour is different than negative pressure. Critical barriers do not affect air changes per hour. To properly supply a containment with sufficient air changes per hour, we need to calculate the size of the containment in cubic feet, then calculate the number of units needed to provide 4 air changes per hour, as required by Cal OSHA. Air changes per hour, you can go through the math and figure out how many negative air units are required to supply 4 air changes per hour, or you can use the following document found in Janus Quick Takes on the company share, J drive. This calculation is for a 5,000 square foot containment with 12-foot high ceilings. So we have 5,000 square feet, total square footage of the containment. The height of the containment, 12 feet, gives us a total cubic footage of 60,000 cubic feet within containment. The cubic feet per minute rating of our negative air unit is 2,000 cubic feet per minute. The efficiency of our negative air at 2,000 cubic feet per minute is going to be 100%. Sometimes specifications require us to do this calculation at 80%. Number of required air changes per hour is 4.0. That is what Cal OSHA requires. Some consultants require us to have that up at 6 or 8 air changes per hour. Put all those numbers in. The bottom line here will give you a negative air unit required number, and it's 2. Cal OSHA believes that the more air changes per hour, the fewer fibers will be in the air. This can work, but only if you set up the containment properly. We'll discuss the above statement on the next slide. It must be understood that gases, like oxygen, expand to fill the containment. Fibers must be moved, pushed, or pulled from place to place. Though not a consideration of Cal OSHA's, Janus understands that by constantly bringing in outside air, workers inside containment are in no danger of creating an oxygen-deficient atmosphere, no matter how well sealed the critical barriers are. In this typical containment, one room, it doesn't matter how big it is, we're going to supply this one room containment with 4 air changes per hour with a single negative air unit that has air moving from inside containment outside. Air will be coming in through our decontamination chamber. This provides some air movement in front of the decontamination chamber just inside containment, but it's not enough to push air all the way over to the negative air unit. Negative air unit, on the other hand, is only cleaning the air out 3 to 4 feet in front of it. After that, it doesn't pull air directionally anymore, and it doesn't create a wind that would pull or push the fibers. That means that when we have it set up like this, the only space being cleaned 100% correctly is the 3 or 4 feet right in front of the negative air unit. Everywhere that you see gray is now dead air, with the exception of this space right in front of decon where the air is coming in from outside, but it doesn't push it all the way across. If we added more makeup air holes, this would allow more air movement, and it would allow that one negative air unit to produce better air cleaning. But this many makeup air holes would reduce the amount of negative pressure. We may not have our 0.02 negative pressure differential anymore. We may be required to add a second negative air unit, or perhaps a third, depending on how much makeup air we're allowing in. Of course, all of our makeup holes have to be HEPA filtered. It's always best to use proper work practices, removing materials as intact as possible, prompt cleanup, clean as you go, and engineering controls, water, wet methods, and HEPA vacuums to keep fibers out of the air in the first place, so we don't have to rely on the negative air units to try and clean our work area. Negative pressure things to understand. Cal OSHA requires negative pressure containments for Class 1 work. Cal OSHA requires 4 air changes per hour for negative pressure containments. Cal OSHA requires 0.02 pressure differential for negative pressure containments. And remember, pressure differential and air changes per hour are 2 different things. Negative pressure helps to assure Janus containments do not become oxygen deficient. Air changes per hour are designed by Cal OSHA to lower the amount of fibers floating in the air in an asbestos containment. Air changes per hour does not do a very good job of reducing fiber counts. It is best to use the proper work practices and engineering controls to keep fibers out of the air in the first place. Thanks for taking today's training. Please proceed to the quiz.